I'm here again with a new topic, that is the dimensional analysis. You know, any physical quantity can be expressed in form of the unit, and the unit can be expressed in different form. Like I'm taking the example of velocity. Velocity, you know, it is the displacement upon time. Displacement is expressed in meter and the time in seconds. So you write here meter per second is the SI unit of the velocity. So we raise a power on the SI unit of the second of the time, and this special number which gives you the SI unit of the velocity is known as the dimensions. So what are the dimensions? Dimensions are the powers which raised over a basic unit to get derived unit. Okay, so basic SI, second is the basic unit, time is the basic physical quantity, and the time, and the second is the basic fundamental, you can say it's a unit. So we are raising a power on the basic unit to get the derived unit of the velocity. So this is the dimensions. So now the dimensions, after dimension we have to discuss the dimensional formula. You know, to get the dimensional formula we express length always as capital L, and the mass always capital M, and the time T. Okay, and suppose its dimensions are A, B, C, then you will write the dimensional formula LA MB TC. Okay, so this is the dimensional. Suppose the dimensions of length is A, dimensions of mass is B, and dimensions of time C. So you will write in this form, and it is known as the dimensional formula. Okay, so this is the dimensional formula, or it is the dimensional equation. Okay, dimensional equation. Now we can practice some dimensional formula of some physical quantity. I'm taking the example. Suppose I'm taking the example I'm taking here for you, it will be more clear to all of you. So suppose density. Okay, you know density is the mass upon volume, and the mass means M, and the volume means cube of the length, so it is the L to the power 3. So ml to the power minus 3, it is the dimensional formula, or you can write like this also, m L0 T to power minus 3. Okay, in this form you can write. This is the example. You can take some more examples like the small g, that is the change in velocity, rate of change of velocity. So it is the ms, meter per second upon second, so it is the meter per second square. So dimensional formula is L T minus 2. Okay, or we can write m to the power L T minus 2. So this is the example of the acceleration due to gravity. You can find like this. Some other examples we can take for your convenience. Okay, I'm taking some special examples. Suppose taking the example of angle. Okay, we can discuss this angle. What is the angle? Angle is the arc upon radius. You know, arc is always in measured length, and the radius is also in length. So it is the L to the power 0. Okay, and one more example I can take, like the strain. Strain is the change in dimension. Suppose along the length I am taking change in the length upon original length. So it is the L upon L, or we can say L to the power naught. So these type of dimensional formulae are known as the dimensionless physical quantities. Okay, so what are the dimensionless? You can find it. So we can do practice of different physical quantities, provided you know the correct formula of that physical quantity. Suppose you have to find the dimensional formula of the say example, suppose capital G. Okay, so to know the dimensional formula of the capital G, you should know the formula of the G. F is equal to G m1 m2 upon r square. So you'll write G is equal to F r square upon m1 m2. Okay, and then you will write the dimensional formula of the force, and R, it is the length, and these are the masses, and then we can find the dimensional formula. So you can write the dimensional formula of any physical quantity provided you know the correct formula of that physical quantity. Now dear students, after this we can discuss its utility, that is the applications of the dimensional analysis. So I'm taking its uses. There are 3 uses. Okay, first uses I can take. Okay, uses of dimensional equations. Okay, so first I will discuss, very interesting, all uses are very interesting, to convert units of one system into the unit of other system. Okay, it means suppose something is given in kilogram meter per second square, and you have to convert it into gram centimeter per second square, like this. This is the CGS unit, this is the SI unit, this is the CGS unit. So you can change and you can find what is the value by which converting factor you can multiply or divide, so that we can find the another unit, another systems unit. Okay, so it's very interesting. I'm to discuss its application example. I'm giving some more detail about it. You know, 1 meter is equal to 100 centimeter. I think it's clear, na? No doubt, na? So this is the SI unit, this is the CGS unit. 1 is the numerical value in the first system, suppose SI unit. M is the mass, so we can write it, suppose it is the U1. U1 is the, that is the in first system unit. This is the N2 is the another numerical value, and it is suppose the U2 which is the another system. Okay, so N1 you can write U1 as M1 L1 T1, and here N2 is equal to M2 L2 T2. Suppose the dimensions are ABC. Dimensions will not change. Here you can see dimensions remain same. Okay, it is the MLT minus 2 na, and here again MLT minus 2. So dimensions are not changing, dimensions will same. So ABC, we are taking the dimensions in both systems as an example. Okay, so you have to find this value. Suppose you have to find like 1 meter is equal to how much centimeter. Okay, it means you have to find the N2. What is the N2? So we can find the N2 like this. N2 is equal to N1 M1A L1B T1C upon M2A L2B T2C. Okay, and you can write like this: N1 M1 upon M2 A L1 upon L2 B and T1 upon T2 C. A, B, C are the dimensions. So using this simple formula, we can convert the units of one system into the units of other system. Okay, taking the example, it will be more clear to you. Suppose I have to convert say Newton. Okay, Newton into dyne. Okay, Newton into dyne. You know that Newton is the SI unit of the force and the dyne is the CGS unit of the. Okay, it means it is the you know very well, it is the kilogram. F means क्या होता है? F is equal to ma. M means mass and A means the acceleration, LT minus 2. So it is the MLT minus 2. Is it clear? It is the MLT minus 2. So it means you have to convert kilogram meter per second square into, or you have to find how much gram centimeter per second square. You have to find it. Okay, this value. And here it is the 1 kilogram meter per second square is equal to how much gram centimeter per second square. I think example is clear, na? So it means here N1 is equal to 1, N2 you have to find. Okay, and this is the U1, this is the U2. So using the same concept, N2 is equal to N1, M1 upon M2, A, L1 upon L2, B, T1 upon T2, C. Okay, N1 is given 1, M1 is given, this is the M1, kilogram given, and you have to convert M2, it is in gram. Okay, and L1 is given meter and L2 is in centimeter. Okay, and it is in given second and it is again in given second. Okay, dimensions you can see here. What are the dimensions? Dimensions A. See what are the dimensions here of the force. M1, A is equal to 1 here. Okay, you have to compare from here. Okay, so A is equal to 1, L is equal to 1 and B is equal to 1 and C is equal to minus 2. From here you can compare. Okay, M to the power A, L to the power B, T to power minus T to power C. So these are the values. So here write 1, 1 and this is the minus 2. Okay, now see the next line carefully. So convert kilogram into gram, that is the 10 to power 3 gram. Okay, meter, that is the 10 to power 200. 1 meter is equal to 100 centimeter upon, it is 10 to power 2 centimeter upon centimeter. Okay, it is 1 only, second will cancel, minus 2. Okay, no value. So now see, so gram will cancel, centimeters cancel. So 10 to power 3 into 10 to power 2, that is the 10 to power 5. So what is your answer? That is 1 Newton. 1 Newton is equal to 10 to power 5 dyne. Means 1 kilogram meter per second square is equal to 10 to power 5 gram centimeter per second square. You have to convert it. Is it clear? This is the first application of the dimensional analysis. In next video we'll discuss the second and third application, and then we'll discuss the limitations of the dimensional analysis. Thanks, students.